In this problem, we are solving an exponential equation. So that means that the variable is an exponent. So one method to doing that may not work all the time, but for this problem it will. We look at the 4 and we look at the 8, and we have to think about, is there a way to make them the same? So in other words, if I change 4 to 2 to the second power, 2 to the second power is 4. I haven't changed anything. And 8 is the same thing as 2 to the third. Again, I have not changed anything. That's 8. So this is the same, and this is the same. So we want to know, when will these be the same? So we're going to take 2x, set it equal to 3, and solve. We get x equals 3 halves, which is the same thing as 1.5. And then remember that you can check this by plugging it into the equation for x. Now you can put that in your calculator, 4 to the 3 halves power, and make sure it equals 8. Now if we didn't have a calculator, remember this is saying the square root of 4, because the index is the denominator, which is a 2. So the square root of 4, and then cube that. So the square root of 4 is 2, and then 2 cubed is 8. So we know it works. It made both sides equal. Okay, same thing here. I'm going to take the 9 and the 27, and I want to try to make them the same. So I know that 3 to the second power is 9, and I know 3 to the third power is 27. So I made these the same. So now I'm going to bring down the rest of the problem. And since these are the same here, I want to make these the same. So I have 2, and then I have x plus 3, which is together, so I'm going to put it in parentheses. And then I have 3, and then I have x plus 2 together. And I'm multiplying because that's what we do when you have an exponent in the inside of the parentheses and one on the outside. You distribute, you multiply. So that's why we're going to distribute this 2 and this 3 here. So we get 2x plus 6. And then here we have 3x plus 6. Now we just have a nice linear equation to solve, so I'm going to subtract 2x. And then subtract 6. And we get that x is 0. So if we plug in a 0 for x up here, so we plug in a 0 there, and a 0 here, check it with your calculator, we should get that 9 to the third power is the same thing as 27 to the second power. Alrighty, next example here. So we want these to be the same. So I know that 4, I could use 2 to get 4. I know that, and I'm going to rewrite this as 4 to the negative first power. So 4 to the negative first, we should know from prior chapters that when it has a negative, it moves it to the bottom. So that's all I did, was I rewrote it. Then I also know that I can take 4, and I can write it as 2 to the second power. But I need to make that 2 negative, so that way 2 to the negative second power, 2 squared is 4, and it would go to the denominator. Alrighty, now we have common bases. So this is the same, and this is the same. Now I want these to be the same. I want to know what x will make them the same. So we're going to set these equal here. Distribute here. So negative 2 times 3 is negative 6x. Negative 2 plus 1, or negative 2 times 1 is negative 2. And then I'm going to add 6x. And lastly, divide by negative 2. We get that x is 1.